Well, good morning, everybody, and welcome to the Lync 2013 over the Wi-Fi network session. I hope you had a good time last night, and actually, I'm really pleased and surprised to see so many of you here. I didn't actually expect to see you, so many people in the room, so that's really great. So I'm Sasha Juratovic. I'm a senior program manager with our enterprise custom engineering team. And I'm very pleased that I have David and Pascal with me today. Guys, do you want to introduce yourself?
Sure, David, go ahead.
Yeah, so I'm David Frost with Ixia, and we do a lot of Wi-Fi testing and partnerships with Microsoft. So I'll be speaking to that note a little bit later.
And my name is Pascal Menezes. I'm a principal program manager in the same group as Sasha in the Lync Skype group. And really being involved in the Wi-Fi for about, since trying to make sure Lync runs over Wi-Fi to begin with, about 2011, 2012. And so I hope you like the session. Sasha's done a great job on most of the slides here.
All right. Thanks, Pascal. So to start, maybe first show of hands, how many of you are running Lync over the Wi-Fi network, so trying to run? And keep your hands up for those of you who are having a good experience, who are having no problems with that. Okay, excellent. I mean, expected. It's hard. It's not easy. A lot of challenges, a lot of issues, and hence why we're having actually this session. So to start with, let me give you a bit of an overview of what we are going to cover today. So just in case there are any doubts why Wi-Fi is important and why we are doing this session, I'll show you a couple of slides at the very beginning. Some statistics, some numbers coming from analysts and some trends that we are seeing. And hopefully that's a couple of slides only, 2 to 3 slides. So hopefully by the end of that, we'll level set in a room and we'll be able to move on, realizing the importance actually of the Wi-Fi. Next, I'll kind of carry on and talk about some challenges when it comes to running the real-time media over the Wi-Fi networks. And then I'll be talking about some common usage scenarios. At that point, Pascal will take over and he'll walk you through some deployment guidance for these scenarios that I'm going to introduce. And he's also going to cover some strategic initiatives that we are running inside of the Microsoft and with our partners to actually improve on all of the challenges and issues that we are seeing today. Pascal is also going to cover some MSIT lessons learned. So a couple of years ago, we have conducted a trial or a pilot in MSIT. We've learned tons of that pilot, and Pascal is going to introduce you to that. And then after that, David will take over and kind of wrap up the session with a Wi-Fi network assessment, a very important piece, and David will talk about that in a bit more details. And hopefully by the end of it, we'll have some time for the Q&A. If not, we'll be kind of around. We are at a booth. Ixia has a booth. We have a booth. So you'll be able to come to us and talk about actually what is bothering you, maybe. We have a lot of content to cover. So let's get it going. So as I said, a couple of slides first. The slides are kind of a courtesy of the Wi-Fi Alliance. And this slide is really showing the shipment of the chipsets in the past years and the predictions what's going to happen in the following years. And then as you can see from the slide, we have shipped, or the vendors have shipped actually 2 billion chipsets by the end of 2013. So that's one important piece of the information. So it's just a huge volume. And then the other one, what is at least interesting to me, is that you can see that the trends are actually flipping. They have been shipping a dual band 11N devices, so 2.4 and 5 gigahertz devices, and that kind of a trend is changing, and they'll kind of continue and start shipping dual band 11N and 11AC devices. One thing actually I forgot to mention. One of the things that I'm not expecting you to take away from this session is just to become an expert in Wi-Fi. That's just probably not realistic. Some of you are maybe, but most of you are maybe not. But one thing I would like you to take away is some of the challenges unique to the Lync and real-time media when running over the Wi-Fi. So You've seen the previous slides, number of chipsets. This slide shows you actually a number of devices. So chipsets are built into the devices. It's a hockey stick. You see the prediction. 2013 finished also with roughly 2 billion shipped devices. So again, a huge volume. Now, what are the trends really that we are seeing? We are seeing our customers, our users actually doing or demanding. So users are more and more demanding actually to have same experience over the Wi-Fi networks as they have today on wired networks. And that specifically I have, when I'm saying that, I have specifically real-time media in mind. So whether they are in enterprise environment, home environment, or maybe public hotspots. So that's one thing. The next thing is that you are probably witnessing more and more users bringing their own devices to the workplaces. And that's the trend you've been probably hearing on this conference and so far as well. That's not going to go away. It's very real. It's going to stay. BOID, as you will see in the presentation as we move along, there are a number of challenges with that as well. The next thing is that these devices typically are more and more mobile, and more you would find devices, users are bringing devices that are Wi-Fi capable only. So there are no other options actually to connect these devices to the networks apart from the Wi-Fi. So it's just the reality that that users and actually whoever is actually managing those networks have to deal with. There are also users, customers, they are also asking for the better or for the greater experience when running a real-time media. So going maybe 10 years back, people were just accustomed to, when the whole Wi-Fi kind of a trend and push started, they were accustomed to and still accustomed to running maybe a mail or browser traffic, so browsing the network and so on and so forth, and having a really good experience when they compare that to the wired network. Well, they are demanding exactly the same thing for the real time, so for audio and video calls, for example, as well. And the other thing also they are saying is that, you know what, and this is, I think, dependent very much on the part of the world. In some part of the world, a cellular traffic is still quite expensive. So what they're saying is, hey, if I have a cellular capabilities, but I'm also have a Wi-Fi capabilities at the same time, I really would like to offload my traffic and leverage Wi-Fi instead of the cellular traffic. The net is that really Wi-Fi has become a mainstream. And from all of these trends and numbers from the previous couple of slides, hopefully, I've managed to convince you that the wireless is a reality and it's not going away, and we just have to deal with that. And when I'm saying we have to deal with that, is I really mean there are a number of challenges, as you will see, that you will run into. So the reminder really of the slide deck will be focused on the real-time media. This is really the focus because data is easy, relatively easy, right? So there are three different scenarios that we as a Microsoft are thinking about when we say, hey, you want to run Lync 2013 over the Wi-Fi. First is really just the data. And what I mean by that is that you would have your laptops, mobile phones, tablets, whatever, and you would be running just a data, so data or traffic that is not real-time media sensitive. So this is your IM, this is your presence, this is calendaring, so forth, and so on. So that's relatively easy, and to be honest, that's not such a huge challenge. I mean, we are, in general, that's working just fine today. The next one is real-time media over the Wi-Fi fixed. So this is kind of a building on a previous data over the Wi-Fi. And it really means, yes, you would be still doing IM, presence, conferencing, calendaring, and all of that, but you would also be doing some audio and video calls. But the way you would be doing that is you would be typically a stationary. So you would be at your desk, you would be in a conference room, you would be maybe at home, but you would be sitting and you would be not moving around. And again, this scenario is, it's relatively, I wouldn't say it's easy, but it's manageable. People are managing to do that today over the Wi-Fi. Now, the most difficult really part is this mobile, the last one. And the challenge here is that it's, again, building on a previous one, fixed scenario. And the challenge here is you would be still doing exactly the same as you are doing in a fixed scenario, but you would be also moving. So the idea is that the end user, will start the call, will conduct the call, and end the call when moving from point A to point B in a building, for example. And this is really, really challenging. So what are the characteristics of the real-time media? Well, before I actually talk about that, let me make a distinction between streaming and real-time media. So streaming, most of you are probably familiar with that. You have used one or the other form of streaming in the past. And typical couple of examples would be a YouTube, so watching a YouTube using your browser on a computer, or maybe a Netflix streaming some movies or whatever down to your television. And the idea here is that you would kind of connect to the service, you would start downloading the data, and as you do that, you would see on the screen kind of a spinning donut telling you loading, 10, 15, 20, whatever %, or it will tell you, well, the streaming will start in 5 or 10 seconds. And what's happening really is that your endpoint, your client, is buffering the data, and then after the 5 or 10 seconds, for example, it will just start playing. And normally the experience after that would be flawless. It would be really, really good because of this large buffer on the receiving side. So there are still a lot of network impediments, a lot of network issues happening along the line, but because of these large buffers, end user would not normally see that. Now, you can't do that with real-time media. I mean, it's just not feasible that if I, for example, I want to talk to David, I start sending my audio, and then David will start actually hearing what I'm talking about in 10 seconds. It's just not manageable. So you would see that when it comes to the real-time media, audio and video, still the same problems, which are really 3 network impediments, which is a delay, packet loss, and jitter. But with the real-time media, this is much, much more prominent than it's the case with the streaming. So what is the impact of these network impediments to us as humans? So you would, when it comes, for example, to the latency, you would see that if the latency between a sender and the receiver goes above specific number, us as human beings would actually notice that, and the experience would start to deteriorate, to go down. Same goes for the same goes for the jitter and the packet loss. There are things that, using the technologies today, we can actually recover. So if you have some sporadic packet loss or even a jitter, our codecs, speaking of the Lync specifically now, our codecs are very adaptive, our codecs can heal, and can actually recover from these situations. However, there are some instances where you have a bursty traffic, where you actually have sequential packet loss, and even with all of the technologies we have, it's simply not possible that if you lose, for example, let's say 3 to 5 seconds of the audio traffic, really, I mean, there is no way around that. These things are lost. So when you combine all of that can be very disruptive for the end user experience. So what is actually a good network? What do we, when we say a good network, what do we have in mind? So first of all, it's a consistent flow of data packets, which is kind of a self-explanatory, logical. You would like what you're sending from one end to be constantly and consistently received on the other end. The other thing mentioned already, delay, jitter, and a packet loss. That's just something that is happening. You don't have, there are certain things that you have very little control of, and the best thing you can do is to try to mitigate. Random loss can be compensated, as I've mentioned already. Some sequential loss, it's much, much harder actually to deal with. The other thing that, especially now with more and more demanding applications, like HD video, for example, bandwidth is becoming more and more of an issue, and something that, especially in the enterprise environment, where you, for example, want to enable video or application sharing, is definitely something that you have to think about. So what are the network requirements? These are the numbers. You would find actually maybe a different numbers in a different literature, different authors. That's a kind of a ballpark. So don't take these numbers as written in stone, as something that if you go slightly below or slightly above these numbers, that thing will start, especially if you go above, obviously, that thing will start breaking down all of a sudden. These are kind of the guidelines, really. So for the bandwidth, you can see that for the audio, it's roughly 50 to 220 kilobits per second. It depends on, excuse me, it depends on the codecs that is being used, it depends on the sampling rates, a number of different things would actually influence the consumption of the bandwidth when it comes to the audio. For the video, it's a bit higher, which is maybe not surprising for you. It is roughly between 250 and 250 kilobits per second and 4 megabits. As far as the jitter goes, jitter is 20 milliseconds. By the way, a show of hands, how many of you understand the concept of jitter, packet loss, and a delay? Okay, most of you, so no need for me to actually explain what is that. Great. So jitter is desired. We would like it to be less than 20 milliseconds. For the latency, 100 milliseconds one way, it's, you would be in a good shape. 200 is still okay. It's not the end of the world. Above that, it could be actually problematic. Now, there are certain things that you have, again, little control over. Things like if, so for example, having a call between somebody on the East Coast here in North America and West Coast, latency would typically be acceptable within the acceptable range and the boundaries. But if you would like to do the same call between somebody in North America and, for example, Australia, there would be a much longer delay. And there is little you can do. It's just the laws of physics. So you just have to, these are the situations that, well, depend on the geography and very little you can do. Packet loss, ideally, you don't want any packet loss, and especially, for example, on a wire networks, definitely should be no packet loss whatsoever. However, on a wireless, it's a bit different story. Less than 2% is still okay, but you also want to make sure that you don't have consecutive packet loss, because that's what is hurting us. So some random loss, anything less than 2%, okay, but sequential loss, 3 packets or more, that's not good. And then last but not least, UDP versus TCP. So you probably know for the link, when it comes to the signaling, we do that over the TCP. When it comes to the media, real-time media, it could be UDP or TCP. Now, recommendation is, and actually when you have everything open, when you don't have firewalls blocking and so on and so forth, media would negotiate UDP by default. And that's something that you should strive for. Just don't, my recommendation here is don't block any UDP traffic on your network if possible at all. Okay, let's look into a bit more specific issues with the Wi-Fi, and especially when it comes to running a real-time media. So these are just Wi-Fi issues. So first one is a handover performance. So what is this all about? So imagine situation in enterprise or larger environments, you have a number of different access points. Let's say access point 1 and 2. You have a client that is connected to the first access point. But then as a user is moving from point A to point B in a building, there is a need for a handover between access point 1 and access point 2. There would be a point where actually the signal would be so low that that experience when you run real-time media over such a network will start really going down because of the signal is maybe not so strong. So really what the client should be doing is they should be moving from access point 1 to access point 2. Now, there are 2 typical problems that we are seeing. One is called sticky clients, and the other one is ping-pong effect. And a sticky client is about saying, well, the client is really drivers or the chipset or whatever, or access points, either on access point side or on a client side, they're really not smart enough to say, hey, it's really bad, there is a better option for me to go to, so I should really stick with the first one as long as I can. That's okay for the data traffic, for your mail, and for your browsing. That's really not good for the real-time media traffic. So that's one thing. The other one is ping-pong effect. So this is kind of the opposite. The client is moving from one to another too aggressively. The next one is off-channel scanning. So what is this all about? So let's take an example, 2.4 gigahertz situation. So the band, 3 typically channels that are in use, 1, 6, and 11, because they are not overlapping. Let's say that the client is actually using a channel 6 for all the communication. And let's say that a client initiates an audio and video call with somebody else using this channel. Now what happens, it's just how it works, how things are working. What a wireless client will do, it will at one point, and quite actually periodically, frequently, it would kind of a step from the channel 6, go to channel 11 and say, hey, who do I have on channel 11? Okay, I have these access points. Okay, fine. Let me go back. And then it would do the same for the channel 1 and say, hey, who do I have on channel 1? Now, stepping from channel 6 to channel 11 and then channel 1 is essentially, it takes some time. And during that time, the client is not talking over the channel 6 and it's doing real-time media, so audio and video call. And if this actually a time that is taking a client to go to a different channel is too long, the end user would notice that. There would be an impact and you would hear glitches or whatever. Rate adoption and the transmission rates. So this is again, this is just things that that you would find on the wireless networks, and unfortunately, the current algorithms are not well suited for the real-time media. So what exactly, kind of a typical example of that would be, you have an access point, and as the client or as the user is moving away from the access point, the signal will start going down. And because of that, a couple of things would normally happen. One thing is that the client will actually do the rate adoption, so it would maybe step from 54 megabits per second, it would go to some lower rate, 24 or whatever. But also at the same time, excuse me, what would happen is that there would be more and more of the transition. There would be more and more failures between a client and the access point. And there would be more and more need for the retries, so for the resend of the packets. And all of that, it's kind of okay. It's just the way things are working. Data and browsing, for example, it's okay with that. Unfortunately, real-time media, not so much. Media admission control. This is very, for those of you familiar with the Lync CAC, call admission control, very similar concept, almost the same, right? Essentially what you don't want to oversubscribe your access point. So there is a certain limit when you have enough clients connected to the access point. You don't want additional clients to be connecting to the same access point. Now, there are different ways, actually, how you can get around that. You can see load balancing is one. So you have a number of access points. You say, hey, this one is just too overloaded. Go to the other one. So actually steering the client, maybe. But the load balancing is, say, go to, for client A, go to this access point. For the client 2, go to the other access point. And then the last point here is signal to noise ratio and the signal strength itself. Now, this is important, and the reason is what works for the data would not necessarily work for the real-time media. If you have your networks today designed for, I'm keep on coming back to that as an example, but it's kind of a mails or the browsing of the internet. Data, SNR, you can see at the bottom of the page, 25 decibels is okay. However, also you can see that the line after, this is not so good or not so well actually for the real-time media. You require at least 40 decibels. And then when it comes to the signal strength, it's very similar. For the data, it's minus 90, and for the real-time media, it's minus 65. So I mentioned a BOID. So a few words about that. So it's just a reality. It's just what's happening today. Now, what is the issue? What is the issue here? You have people bringing their devices. They're typically consumer-grade devices and devices into the enterprise environment. Now, enterprise environment is specifically tuned for the, enterprise devices, and some functionality and features are switched on. And what we found actually in MSIT, one of the lessons learned is that if you do that and people start actually bringing their personal devices, that would not work. I mean, simply you would, in very extreme cases, the devices themselves would not be able to connect to the wireless network. So, and even when they do, there would be a difference in the experience compared to the enterprise-grade devices. So the net result is that, on one hand, you have a very frustrated users because the expectation is, hey, you gave me this laptop or a tablet for my day-to-day business usage, and then I have Also tablet, it is a different tablet, but end users really, or the phones, but end users don't care. It's a tablet, it's a phone, right? It should behave and work the same way. But because of typically a difference in a spec or characteristics, it would not work. So frustrated users, and at the same time, you have frustrated IT department as well, because they would be sometimes forced to say, okay, in order to accommodate for the BOID, I have to start actually tuning my environment to kind of lower the bar and allow them actually to have a good experience, relatively good experience as well. That's one of the reasons why IT departments are saying, you know what, no, for the BOID, you can't do that. Use either a wired or the cellular network. Now, obviously, the challenge is specifically when it comes to the wired, as I was saying at the beginning, majority of devices, mobile devices shipping these days, they would not be able to do that. So that's kind of a bit of a challenge as well. All right, so let me walk you very quickly through some common usage scenarios. And Pascal will actually drill into what are the deployment recommendations and challenges that we are finding in these scenarios. So the first one is enterprise fixed. It's straightforward. You have a couple of people, John and Diana, they're in a conference room, they're using their laptops, they're connected over the Wi-Fi network. They are conducting a conference call with a bunch of people. They're starting with audio, adding video, and then eventually potentially a whiteboarding as well. And as they're doing that, the expectation is they're expecting to have a good experience during the call and when they end the call. The next one is a mobile scenario. So in a mobile scenario, again, you have Brian, and Brian is working at his desk. He receives a call. He takes the call on his mobile device. So he's having a UC application Lync on his mobile device. He takes the call on the device, but then realizes that he's running late maybe for the meeting. He has a meeting in 10 minutes. And he, in order to actually go or in order to meet other people in 10 minutes, he actually needs to start walking away from his office into the conference room. And while he's doing that, the expectation that Brian has is that he would have a good experience having a call, no glitches, no interruption, and so forth and so on. Okay? And when he actually gets to the destination, ends the call, and goes into the meeting. The next one is a home office scenario, I should rather say, and then small office, home office scenario. This is kind of an example of that. Lisa is a work-at-home mom, and what she tends to do in a day, she kind of joins occasionally meetings using audio and video to discuss maybe a business proposal. And at the same time as she's doing that, she has a couple of kids at home. They came back from school. One of them is actually on Skype maybe talking to his friends, so audio and video call. The other one is actually watching or streaming down some favorite series or movie over the Wi-Fi onto the television. And then the last one is a hotspot scenario. In a hotspot scenario, you have John. He's in a local coffee shop. Local coffee shop is actually providing also, it's a kind of a hotspot as well, providing a free Wi-Fi. John is kind of syncing an email. He receives an important mail that says, it's something that I need to deal with right now. There is a link in a mail, kind of call the number. He calls the number. He kind of touches on the number. That opens his Skype client or the Lync client. He conducts the call, good experience, ends the call, and then he can enjoy the coffee. So these are kind of 4 scenarios, and around these 4 scenarios, we are building some deployment recommendations, and Pascal will actually walk you through guidances, issues that you would be finding in these scenarios now.
Okay, thanks, Sasha. Well, good morning, and thanks for hanging around. I'm sure most of you guys are going to be heading out today. So let me start with how many people are here that are operators of hotspots or operators of any kind? How about operators of enterprises? You know, admin, Wi-Fi admin, operators, Wi-Fi architects. Okay, the majority are vendors. Okay, maybe it's Friday after the party and too much party last night. Okay. Anyways, let's just get on. So I'm going to cover the enterprise, the deployment guidances for enterprise home hotspots. I'll give you a little background. We started this project 2011 in September, and we've learned so much. It's unbelievable. And so the idea here is like to convey a lot of this to you guys and hopefully make your deployments go better. We're going to start with enterprise, some design considerations. So basically, what we're finding is that, when we started this, our UC client had not actually, the mobile client hadn't yet shipped yet. So we had a lot of people were using UC with their desktops, and they had their handsets, that was attached USB or Ethernet connected. And that was the majority of it. And then we didn't really support Wi-Fi for 2010, Lync 2010. Even though it was doable, we didn't officially support it. It was like best effort. In 2013 was starting to come out, we realized we needed to do that because the tablets were coming in. We had smartphones, which we had clients for all the smartphones, and we realized that the only single kind of media connection to that is Wi-Fi. So we had to really figure out what to do here. So what we've learned is that over time is the average user of your enterprise is actually having about 2.5 devices that's going to be attached to Wi-Fi, or 3 devices. And when I say that is, like today I carry a smartphone, I carry a tablet, and I carry a laptop. And I don't know why we need all 3, but anyways, it's the way we are these days. And so all those 3 are connected to Wi-Fi because they don't really have Ethernet per se. And so that's something to be aware of, because when you start designing your APs and how many stations will be available per AP, that kind of loads, you're going to have to be thinking that the amount of Wi-Fi demands from users are increasing. And who knows, maybe they'll even go more devices with all kinds of stuff, wearable stuff and all that. Do you have ubiquitous coverage? This is real important. The coverage you do for your data, when you did data with, for your conference rooms and your lobbies, is fine. And data can actually get through, very weak signal strengths, and it'll retransmit and all that, but who cares? You'll finally get it. You will not get the same experience for voice and video if you try to do this. So like Sasha said, the majority we're going to cover about is give you good guidance about voice and video, because that's probably what you're after. I don't think there's any rocket science how to do just regular data over Wi-Fi. Is your network ready for BYOD? I think Sasha talked about BYOD is a huge problem. It's plagued with a lot of driver issues, and we'll cover some of the things we've learned and some programs we're putting in place to kind of handle this. And then finally, end-to-end QoS. If you want to do real-time media, you need to have end-to-end QoS. And end-to-end QoS is complicated. It's expensive to set up. It's by default, Lync does not have QoS turned on. You have to turn it on. Sasha's going to go through that guidance of how to turn that off on Lync. Then you have to also make sure QoS is turned on correctly in your infrastructure. And more importantly, even if you get that right, chances are things are going to change over time. We call it configuration drift, and what you think was correct will not be correct. And a very common problem is you have the network infrastructure somewhere on the wired side will strip off QoS, even though that Lync servers are saying there are QoS tags after you turn it on. Somewhere in the infrastructure, it'll be stripped off. So when it gets to the controller or the AP from the downstream direction back to the station, you'll probably get no QoS. So these are the very common experiences we've learned over time, that we think we know what's going on, but it's not going on. So let me keep going here. Enterprise planning. So obviously, one of the biggest planning you have to be thinking about is the density and where you're going to place all these APs and the coverage. You're going to run voice and video, and you're going to run the scenarios around mobility, then you're going to have a very good coverage that doesn't have any brownout blackouts spots. If you're going to do the fixed scenario, you're going to have to think about where people are going to be running voice and video fixed, obviously from maybe their desktops or conference rooms or lobby areas. But in general, it just makes sense to just blanket the whole building. Obviously, it's a higher cost of APs involved, but you just might as well get ready for mobility, because mobility is the scenario that everybody's going to go after. The other type, we talked about BYOD. The other thing is you probably want to be thinking about 2 different SSIDs, one for battery saving for devices that are smartphones that don't charge so easily versus laptops. or access to power to charge so easily. And so you'll probably run a mobile SSID that will change the DTIM timer, which in essence will give you the time that the client will sleep will more than be awake. And so that will save some battery. So there's lots of technical parts to that, but that's in general. You'll have a mobile SSID that people will join to for their mobile devices, and then a regular SSID guest for their normal. And then the guest SSID will have different policies of access control rules. Talked about QoS. We'll talk a lot more details. And Sasha in the presentation has a really great section about how to turn on QoS on Lync. And it's very detailed, and he's going to do a great job. Infrastructure recommendations continued. So if you have legacy gear that was doing all the data stuff, you really want to go to 11N. And unfortunately, the rip and replace is the best way, because in essence, you'll pay more CapEx today, but if you don't do that, you'll spend a lot of time in OpEx of trying to troubleshoot a lot of problems. So go to 11N, or 11AC is the gigabit, newest version coming out. From 11N onwards, you're going to be pretty safe. If you deploy 11N onwards, you're pretty safe. And the main reason has the WMM, which is the QoS prioritization for Wi-Fi. And WMM, wireless mobile multimedia, is mandatory. To be 11N certified under WFA, you must support the wireless mobile multimedia parts of that. And that's a huge help. And we'll go a little bit in details of that, hopefully, about how there's 4 classes and how you map diff-cert code points through the WMM layer. Let's see. There was a spec called the Voice Enterprise spec that was done by the WFA to handle voice over IP over Wi-Fi. It started a long time ago, I think 5 years or more, I can't remember. And unfortunately, a lot of AP vendors do support it, or some, and most device vendors don't. So, and the other drawback of the Voice Enterprise spec was it was only designed for voice, not for video, and video is obviously becoming big. It didn't test for performance criteria, handoffs, mobility scenarios, off-channel scanning. It didn't do any of that. It just gave these guidelines that you must implement 11K, 11V, and it's like pick performa. So these protocol guidances on what you need to kind of support. And if you did that, you would just pass. So to us, it just didn't seem like this was really going to solve the UC problem, and especially going from voice and video. And video is very common. So we'll talk about what we're doing in this area to drive to what we call a mobile multimedia kind of scenario coming up. Obviously, WPA2 for security, everybody implements that, so that's a no-brainer. You need to do that. Fast VSS transition support. This is all about caching the keys, and so you don't want to be disassociating and then reassociating, and then that's just the roaming, and then you have to go get the keys, and so get new keys every time you're moving between APs. That's not going to work. So there is a standard, I think it came out 11i, and correct me if I got this wrong. Opportunistic key caching showed up very early days around the WPA 11i stuff. And so that's kind of like in every client, every AP. So that's really a great mechanism for key caching. And so when you do mobility, you can get away with, to like, I can't remember, like 50, 100 milliseconds where it'll just transition. If you don't have this enabled, it'll take you seconds. And that will affect, when you're running a voice session and you're moving between APs, it'll affect where there'll be no voice or video for those seconds while it's doing that key caching, key negotiation. 11R is the new standards that's come out to replace OKC. It's a much better mechanism, but it also has huge dependencies of operation, the operating systems to make changes. It's not that simple. It's much more complex. So not all operating systems support it, which hence Voice Enterprise depended on 11R, and 11R really didn't get into many operating systems, and it's still spotty. So that's kind of where the problems are. The QoS WMM planning, we'll talk about that. Basically, Sasha will talk about that a lot in the Lync side, and I'll cover some more about that in the Wi-Fi side. Basically, in essence, if you do the right things on the Lync side of the server and the client, it should, but not always, map through from the diff-cert code points through the operating system and hit the drivers and map into the WMM buckets, the tags that they'll put into the 4 different classes. And things should work right. But not all operating systems do that correctly. But today, more and more are getting better at that. And we talked about power saving. RF planning. So you want to be thinking about the 2.4 gig, the ISM band is highly, highly used by lots and lots of different types of devices, including 2.4 is preferred because it has a huge, great distance capability. The devices that are much more inexpensive really only do 2.4. They don't do the 5 gigabit uniband. And so, in essence, you really want to make sure your APs are supporting both. And what you want to do is on your APs is you want to be buying enterprise-grade APs, which is real important, and not buy the cheaper, kind of home APs and try to use that to deploy in your enterprise. It just won't work. And so these enterprise-grade APs, what you'll do is you turn them on with both bands, 2.4 and 5 gigahertz bands, and basically you want to have like a good backhaul, so like a 1 gig backhaul from your APs. And then the bottom line is that you want to be able to steer what they call band steering. These enterprise-grade APs have the ability to band steer, where they take a client and they can see the client has 2.4 and 5 gigahertz, and they'll move the 5 gigahertz clients into the 5 gigahertz area of the APs and leave the devices that only do 2.4 and put them in the 2.4 gig. And so the reason you want that is the 5 gigahertz band has obviously a lot more channels, and so therefore, and less linear interference. However, it has very smaller distance capabilities. It just has to do with RF. And so, in essence, though, if you're planning your APs correctly, and you're doing it probably every 60 feet apart, and depending on, we'll talk about open designs and wall designs, then what happens is, distance is not going to be an issue in the enterprise. So you'll probably get, pretty decent coverage, performance, and power, and so on. So that should not be an issue. In the home, it's a whole different area. So that's it. In the 2.4 gig bands, also, you want to drop all that 11B stuff. Your clients, if you're still running 11B clients, you don't want to be supporting that stuff because it'll drag down the performance capabilities when it has to negotiate to the lowest denominator. And the other thing is on 11N, you want to be doing 20 megahertz channels instead of 40 megahertz channels because there's only really 3 channels you can use, 1, 6, and 11. And so, so basically, that's really what you want to do. Let me see what else here. Capacity planning. So I think Sasha talked about the idea. If you run voice and video and you run data, you could actually run data at minus 90 dBm with a signal to noise ratio of 25 dB or even worse sometimes. And things will run slow, but it'll work. And so users will just get it as saying it's just slow. If you run voice and video on those same kinds of performance or those same kinds of characteristics, you'll have a horrible experience. And so what we found is that 65 dBm is really that threshold you want to be aiming for, and 40 dB for signal noise ratios. And this is very important because this is where we know there's a sweet spot when you get those kind of levels or better, where you'll get a great quality of voice and video, and you will get less retransmissions, because retransmissions have no bearing for voice and video. It doesn't really help. So this is where you want to be, and so it's all about that AP placement. So I can't stress how important it is that when you're deploying for voice and video, and more than likely you're going to think of a mobility scenario because you're going to get there anyways. Those AP placements are critical, and the difference between open space design and a wall design is going to have a user effect of where the APs are, how far apart they are, and what channels they're using, and so on. And hopefully, I think in the next slide, go through that. Let's see what else. The coverage, okay, we talked about that. So we talked about that. Okay, cool. So open space designs and wall designs. So let me give you some experience we learned. And I'll talk about the dog food we did. We call dog fooding is where we do this piloting stuff. What we learned was we had a really great, in Building 30 and 31, we'll talk about that. We have in Microsoft our own offices. And they're actually full walled offices, not cubicles. They got full wall ceilings. We're all closed off. And everybody's got their office, and there's these hallways. And basically, you have APs every 60 feet on the hallways. And the design on that one, when we did the dog food, was pretty phenomenal because the walls, absorbed a lot of attenuations and all that. And so we could use the channels correctly and not get interference from a channel of one and show up, 3 APs later back and interfere it and cause a lot of interference. So because the walls absorbed a lot of stuff. And so things were going really great. And then we moved, we moved to another building, which was in the Skype design. It's like a Facebook model. There's no offices. We're all big desks and just one big pool. And so that open space caused all kinds of new griefs that we hadn't even thought through. We were getting a lot of interference, or we were getting channel overlapping. Even though the AP distances were really far apart, they were having a huge effect. So the lesson learned is that open space designs and wall designs are radically different in deployments. So just blanketing more APs to get more coverage doesn't work as well in the open design. You want to have less density. And so these are all the things you got to be thinking about. Unfortunately, we'd like to get to the day where we can actually have a standard where a lot of this guesswork is gone. And we could have tools, and we do have some great tools and some great professional services that are actually helping customers with this. But it is not like Ethernet, You just plug in and you go. It's more like, if you can remember the days of, and I don't know how many people are, probably I'm going to show my age, of hubs. If you remember hub technologies and token ring and before switches came along, it was that, okay, well, how many users per shared LAN and all that thinking, and that's where we are in the Wi-Fi days. It's kind of like that kind of area. And what I mean by Wi-Fi days, I mean for voice video versus data. So that's really important. Surveys. So if you're going to deploy, after saying this, if you're going to deploy real-time media over Wi-Fi, you really want to have a really great pre-site survey done of the building, the layout, its open space, closed space, hybrids, really understand where these APs are going to be placed, and basically really get some good architectural understanding about this stuff. And there are professional services. If you can't do it yourself and you're not a Wi-Fi expert, you can hire professional services, people who come in and they know what to look for, and they got tools to check for attenuations and things like that. Then, after you've kind of figured that out and you've deployed this into the building, you want to then do an assessment to make sure that what you think is going to work is really going to work. Because you'll be surprised that what you think is going to work to what's really going to work can have some discrepancies, and you'll have to do tweaks. Unlike turning it on just because you think it's correct and then have users come on and then you'll have all kinds of problems and complaints, it'll add to a lot of frustration. We went through this, and we had a lot of complaints, and it was like, chasing things all over. If we were just done the post assessment correctly after the deployment, we would have solved and mitigated a lot of these issues. Enterprise client recommendations. So I'm going to tell you, after we figured out the AP side, and we spent about a year plus, and I'll talk about what we did in these certification programs, but we call them qualification programs for legal terms, for the AP side. We looked at the devices, and the devices are plagued, and I can't even stress this. When it comes to real-time media or Wi-Fi, they are plagued with issues. And they're getting better, but it's still a real problem area. And so we'll talk about what we're trying to do in our certification programs, or again, qualification programs. We don't call them certification. And then what we're trying to do in some standards committees under the Wi-Fi Alliance to support this. But things that you should be aware of is that the day I give you, the day that the enterprise gives a certain device and says, like your laptop, here's your laptop, it's sanctioned, it's tested, is going away. And more, especially for the tablets and the smartphones, is you can use it, and they're not domain joined, and they're your own devices, and it's a plethora of problems to support. And when they don't work, they will call your help desk, even though you guys don't own the device. There will be a set of problems. And it really stems from a bunch of things. It's just that for some reason, the chipset vendors have not really gotten to a full, even though they know this, they've not really spent a lot of energy to make sure voice and video runs right. And so they all have, and since there's no standard to test this, they all have their own algorithms, their own ideas of how to see the world, of how to do this right. And so things that get affected about this are real experiences that just issues like, for example, that bugs in the drivers for voice and video where, for example, 11N is a block act so that it has higher performance. In one of the chipsets, the third spatial channel was not, where the block act was being sent and was not being sent, and it was causing all kinds of problems, and only was doing that on the 40 megahertz versus 20 megahertz channels. And it was crazy stuff like that. Another one, for example, I'll give you an example, is that certain chipset, because they thought they were doing the right thing, that when they were plugged in power, they would optimize it high power for the Wi-Fi chipset. But to save battery, when you unplugged it, they would bring down the power. Well, for data, that's okay. For voice and video, that's a no-no. And try to troubleshoot that was hard because you just didn't expect that to go and you're looking at the advanced part of the driver to see it, and there's no group policies from AD to go set that or anything like that. So lots of issues like that. The other issues also, for example, was 11K. We had certain major device tablet manufacturers that just didn't do the right things with 11K. We'd turn on 11K in the AP. We would get it from the device. They were supposed to work, and they were supposed to do all that resource management and make it better, and it just wasn't interoperating, and there was all kinds of problems. We had to turn it off. So you expect that if you're going to have BYOD, which you will, you are going to have a set of problems. And what we're trying to do, hopefully at some point soon, we'll have a wiki, a public wiki, because we're capturing all these problems ourselves. But from legal terms, can't really, and I'm not sure what we can expose of, this manufacturer of this device has this problems. Is what we're trying to eventually get to. And we'll talk about that, the device certification program, trying to make this a better world of getting rid of these BYOD issues. So the lesson learned out of all of this is what I'm trying to say is that what you're going to find is you're going to get the AP part done right by doing all the right architecture work, the post surveys, and then you're going to say, okay, it's open for business, and then these users will come in with these BYOD devices, and you're going to find a whole new set of problems come up, and they'll all be device-related, driver-related issues that you're going to have to weed through. So it's where the reality is, unfortunately. Home recommendations. As you know, a lot of people are telecommuting. You can't tell people that you have to upgrade to 11N kind of AP, but 11N is what you want to do because it has built in, again, the wireless multimedia for QoS, and QoS is so critically important, as Sasha will talk about. Also, again, if you could get 5 gigahertz, it's way better because you're going to have a lot more home interference at home than you'll have at work, because you're going to have your gaming systems, and you're going to have Bluetooth devices and cordless phones and tourists. I mean, my whole house, every room's got a cordless phone, and most of them, are kind of gone from the 2.4 ISM band and are now in the uni band, and so. But you're going to have to be aware of that you're going to get interference. And the other biggest thing I find is that 5 gigahertz runs really well, but only like if I'm in my downstairs area in a certain area, and then as soon as I go in a certain bedroom, it doesn't work right. So when I put 2.4, it works everywhere, but then I get interference. So you're going to have to either deploy more APs or extenders, repeaters running at 5 gigahertz, or you're going to have to use the 2.4 gigahertz and deal with something interference. And The other one that's really problematic is like I can see my neighbors, even though there's houses apart, their stuff comes in, and everybody uses channel 1, 6, and 11, so the bottom line is that you will get interference in that 2.4 gigahertz just from neighbors, and especially if you're in a condo or apartment, it's even worse. So let's see what else. Okay, so that's what else. Hotspot recommendations. There are not a lot of hotspot vendors here, but the bottom line is I tell everybody, if you're a hotspot vendor, just buy the enterprise grade APs, buy the stuff that we're qualified, certified, and then you pretty much have the same problems as you have in an enterprise. It's all about where you place the APs and all that kind of stuff. Unfortunately, the airports suffer like convention centers. They have a large amount of users in certain dense areas, and so the AP can only handle so much. And you try to load balance, and you try to band steer them to other APs, but the other APs might have, poor performance of attenuations and things like that. So for voice and video, they might not get the optimal experience. So this is the kind of stuff that these hotspot vendors have to deal with. So configuring QoS for your Lync deployment, I'll let Sasha talk about this. I can't underestimate that if you don't have QoS correctly end-to-end in not only your Wi-Fi, and your Lync, and all your wired, and it's not properly tweaked with all the right tagging that maps all correct for voice, real-time media, and video, you're going to have problems. And it might not show up for days, and all of a sudden it'll show up on this blip for a little time. You'll get all these calls come in, and then you're like, what the hell happened? And this is all has to do QoS and misconfiguration. So take it away, Sasha.
Thanks, Pascal.
Are these slideshows going to be posted?
Yes, including recordings, everything, yes. Okay, so what I'm going to cover in the next couple of slides is I'll focus just on Lync. How do you do configuration, QoS configuration on a Lync? I'll do it for the service, media endpoints, so your mediation server, application server, and edge, and then I'll also be doing the same for the Lync desktop client. But before I actually do that, let me say what you have to do for both. So in a nutshell, first you have to do a port configuration. What you have to do is to say, when the packets, audio, video, application sharing, are coming out from the station or from the server, they are coming over a specific ports. And there are two things that are important here. One is, this is more like a recommendation, you would like across of your deployment infrastructure to be consistent. In other words, if you are using X to Y port ranges on a server 1 for the audio, you would like to use exactly the same port ranges on a server B, C, D, and so on and so forth. So that's one thing. The other thing that you would like to do is to avoid overlapping. You would like to say, okay, I'm using this range for the audio, and I'm using another range that is not overlapping with my audio range for the video, and then I'm using a third range for the application sharing. So that's one thing. Excuse me. The second thing is to say, okay, now that our packets are actually coming out of the server, and I know that I have this separation, I would like to tag those packets. I would like to apply quality of service on these packets, and I need a mechanism to do that. And this is kind of the second major bullet point on this slide. And there are a couple of ways to achieve that. So on the later versions of the Windows operating system, like 7.8 or the Vista on the client side, or as you can see, 2012 or 2008 R2 on the server side, you would be using quality of service policy. And I'll be focusing actually on that in the following slides. If you, however, still have some Windows XP devices, hopefully not, but just in case if you do, then you do have a bit different a mechanism called Quality of Service Packet Scheduler. Yeah?
Is there any way to configure QoS of phones or any kind of mobile devices?
Yeah, so for desktop phones, so that's kind of going towards, yeah, I'm going to touch on that as well. Give me a second and I'll cover that. So, so for the phone edition to start with, yes, we are doing, yep, I'm coming to that as well. So for the phone edition, we are doing the marking by default DSCP40. However, you can change that with a commandlet that you can also see on the screen. For the Mac, we are using preset values, CS5 for the audio and CS3 for the video. And then coming to the mobile devices, on the mobile devices, it very much depends on the platform. Some platforms allow us to do marking, some not, unfortunately. across the board, depending on the platform, there are no ways to change. Talking about Lync now, there is no way to change that, unfortunately, today. We are working on that. We are working to improve that, but you can't change that as you can, for example, in some other cases today. Now, let me cover the server side. So there is a conferencing, application service, and the edge service. And when it comes to configuring port ranges, it's a bit different what you do on a conferencing and application service and what you do on the edge service. So on application, on a conferencing and the application server, the most important thing, and again, Commandlet can tell you that, is to configure application sharing port to not overlap with the audio port. So by default, unfortunately, that is the case. However, you can change that with a commandlet, again, that you can see on the screen, and achieve this non-overlapping that I was talking about earlier on. On the edge side, it's a bit easier. The only thing that you do is actually define a port start and a range, a number of ports that you would like to use. So on the left-hand side, you have a table that is kind of a default out-of-the-box table with the values for the Lync 2013. The only thing that you have to do is to change application sharing port. And once you do that, then you move to the right-hand side and you configure the edge using the commandlet again and values in a table to achieve kind of the match between the two. So you have configured the ports now on a server. Now you have to apply really policies. And the way you do that is to open a group policy editor. You can see the path. And on the right-hand side of the screen, you can see a screenshot of how it looks like. So for each and every modality, so audio, video, and application sharing, you have to go through the wizard and specify the values really that are in table. I mean, you don't have to specify the exact values that are in table, but as long as you are consistent across the board in your deployment, you'll be fine as well. So that's one thing that you have to do. Once you do that, you initiate GP updates for us if you would like these changes to apply immediately. And then there are a couple of situations where you would like to set this registry key that you can see on the screen as well. If you are running a multi-adapter system or if you have a machine that is a workgroup machine, in that case, you should really apply it. Otherwise, the whole thing will not work. Now, the difference between MCUs, so conferencing and the application server and the edge is very, very little. It's minor, but still enough of a difference, so you can't simply copy and paste everything. You can observe that, that the table looks almost identical. So the table on the bottom looks almost identical to the table above that, but the difference is in red. So for the conferencing and application and the mediation server, we are using the source port ranges. On the edge, we're using destination port. So the net is that on edge server, you have to follow exactly the same procedure, go through exactly the same wizard, specify audio, video, and application sharing, but just focus on the destination port range. Now, on a client side, client is very similar. I would say almost identical. When it comes to, there are minor differences, obviously. When it comes to the port configuration, by default, you can see on the left-hand side that client media port range enabled is set to false, which is essentially to say, we are not using the port ranges in the deployment. You have to change that. So you have to issue the commandlet on the right-hand side to set it to true. And then, as you can see, the numbers on the left-hand side are marked in red as well, meaning that they're overlapping. And again, you don't want that. So on the right-hand side, commandlet would give you an example of non-overlapping ports. And the table below is a sample table that you can use in your deployment today as well. Once you do that, you have to configure a quality of service policy, and this is exactly the same process and a procedure you have done for the server. So really nothing much different here. You just kind of go through the same procedure, through the same wizards, and then apply these four audio, video, application sharing, and file transfer. You can use the kind of values from the table, and you should be good to go. So at this point, I'll turn it over to Pascal to quickly talk about the strategies, MSIT experiences, and then we'll wrap it out with David.
Yeah, thanks, Sasha. So we might just run a few minutes late, but I'll try to make it fast here. I've covered most of the stuff. So do you want to talk about that when we started this program, what we did was, after we've learned all this stuff, we put in this, what we call this qualification program. This qualification, again, from legal terms, we call it qualification. It's a certification, but legally we call it qualification. It's a softer. The qualification program was really designed to certify a bunch of AP vendors that would actually know that they do the right things to all our deployment practices, to have the right feature set. One thing, like for example, RF management I didn't cover, that they have RF and power management systems, that they automatically tweak everything correct, so all that kind of stuff. So these are enterprise-grade kind of vendors that supply APs and controllers. And this qualification program was like 200-page test documents of testing to make sure things run right. Ixia is our test lab that is not only an incredible leader in this test and measurement space, but they actually went for us specifically. They have this very cool RF tool, maybe I'll talk more about, that actually they acquired this this system, and they put it in a Faraday cage and all that, and they can test these APs in this and test for all these scenarios and all that. So the AP vendors, again, with the qualification, we test for real-time media for mobility, real-time media for fixed, and then just data. And this program is published under the UCOIP. You go Lync space UCOIP, and you can get that. And you can see all the products that are qualified, including, as you can see, Cisco's in there too. Okay? So that's one thing. That's done, and it's expanding, and we're going to be expanding that to 11AC. This is right 11N only right at this point. The next one I want to talk about is the device qualification program that Ixia is about to launch. We're going to launch this. Ixia is, again, the partner to do this. And what we're doing is we're taking actual devices, certain category devices from manufacturers. We're going to run them through this really rigid test of mobility scenarios, off-channel scanning, interference, how they do with distances, where the antennas are, and all that kind of stuff. And really, it's going to be a really, really great program to actually show the deficits in some of these devices, so you are aware of it. And if you are a manufacturer of devices and you want to join this, just contact me, because we are now about to open the program and bring in these manufacturers. That will be published just like the AP side. And this is all about a pre-qualification to actually where we want to get to a certification, where we're influencing the standards committees, the WFA specifically, to have a standard version where all the devices, all the APs, actually are certified for like a UC or mobile multimedia kind of scenario for voice, video, data, for mobility scenarios, for all the scenarios that we talked about, that Sasha talked about in airports and homes. And we there, I can't talk the details of that, but we are actually very much, Microsoft is championing and driving this hard. And I think you'll be pleasantly surprised soon of what the results will be of this. That will then become the de facto industry standards of certification for both APs and device, and that's what we're trying to get to. So I'll cover the MSIT lessons learned, and then I want to turn it over to David. So we don't need to cover a lot because I covered it, but the bottom line is the thing that's really interesting is, as you can see on the top here, we did those buildings I talked about. We did closed building designs, open building designs. And what we came up after about 2 years of this dog fooding, a year and a half, 2 years, was we went from 7% bad calls on wireless to 3%, which almost matched. You'll never get zero in wireless. That's fact. You're just not going to get zero. And in Ethernet, we were getting maybe 1%, but we were close to Ethernet, 3%. So we were quite happy with this compared to what it was before. So we learned a lot. Everything we learned in these buildings now is being deployed globally across Microsoft to every campus, to every building. Is now a big refresh going across the world to this, all the lessons learned throughout this to support Lync and voice, for voice and video. There's some general guidance deployments documents. A lot of things we talked about are there. You can see the link. You can get it, and so on. So what else? Lesson learned. I covered a lot of the issues about, It's open space, closed space, BYOD, client issues, and mobility. Sticky points, I think Sasha did cover the idea of stickiness. You'll find a lot of the clients today, when they go to be mobile, what you'll find with that is that they will probably stick to an AP, have very poor signal strengths and signal noise ratios, yet even though there's a better AP, they don't have that intelligence to look ahead and be proactive and see the full scope and try to figure out. They don't have that capability yet, and most of them don't. So you'll find if you try to do mobility scenarios with your smartphone, Lync client on it, walking around with it, you'll probably have issues. That's all the kind of stuff we're going to solve. So with that, let me bring up David, because we have like 5 minutes, and I want to give him some time here.
All right, so for the sake of time, I do apologize. I will try and make this brief and skip through some of the material so we can kind of get to the brunt of what I'd like to do. In terms of Lync and Wi-Fi and how Ixia partners with Microsoft today, what we're really focusing on is leveraging how we test APs for the qualification program, as well as the soon-to-be announced client device qualification program, and leverage the expertise and tool sets to then get into offering a network readiness assessment. Whereas we work with either the end user in IT or an integrator channel partner to benchmark and bench assess the local ecosystem to ensure not just low-level RF coverage and heat mapping, but also how the Lync deployment and Lync experience would be throughout the ecosystem, and that's really, really critical. So again, I will skip through a lot of it because a lot of this was covered. Overall, Lync and Wi-Fi, especially now, it's more and more prevalent. Fewer and fewer people are going into the office and plugging into the LAN drop. Wi-Fi, especially BYOD, as Pascal and Sasha mentioned, is really the way things are moving forward. So it's very critical to get a good glimpse of how your Wi-Fi architecture can handle that type of application load. So in comparison with Ethernet, again, pretty, I don't want to overstate the obvious, but different drastic differences between how Ethernet and Wi-Fi handle this type of application layer. Everything from PHY data speeds and full wire rate. Obviously, you'll get that on the LAN side, but on the Wi-Fi side, you don't. And a lot of these caveats really have to be accounted for when you're actually deploying software such as Lync or re-architecture. Mobility, as they touched upon earlier, stickiness, and the ability to effectively and seamlessly go from one location to another, be switching from APs and doing different roaming. And all these are different elements that need to actually be benchmarked to ensure a good experience. So Wi-Fi networks, again, they rarely will outright fail. Most are operational, offer coverage, but it's not optimized, not really dialed in, and that's a really, really difficult situation to detect and fix. So kind of what you're going to see here is a very high-level picture of kind of what we do and how, I'll get into how we do it, but what you're seeing here is stark contrast between two different results of heat maps. One will show signal strength and coverage, and on the surface you'll see all the green, everything looks fine. You're able to go ahead and roam effectively and still maintain signal strength and coverage, but that doesn't always translate to good application experience. And that is really the big differentiator. It's not just coverage, but what's your QoE? What is your TCP good put? What is your roaming time, co-channel interference? All the different elements come into play that offer a very different picture when you're actually running Lync and trying to maintain that call quality as opposed to just having basic signal strength coverage. And these are types of things we uncover when we offer the assessment. So again, in terms of overall Wi-Fi infrastructure and how we do assessments, two different aspects are considered when we offer an assessment, either the WAN side or the Wi-Fi side, or a combination of both. I'll skip through. You can see some of the very technical flow charts here. In terms of doing a BYOD Lync session, it could be localized to the AP and the controller. A lot of that would be consistent of how we do a local Wi-Fi environment assessment. As opposed to on the WAN side, we can then take this one step further and go campus to campus or site to site and really benchmark the link experience over the WAN links as well, in combination, in conjunction, if you will, with the Wi-Fi localized ecosystem as well. So we stress the systems by not only we have the ability to generate actual traffic and ecosystem background traffic, but we also incorporate the local BYOD devices and the localized clients within your ecosystem, meaning your smartphones, your tablets, laptops, et cetera, are all actually part of the test. And that's really important because you don't want to get a completely synthetic view. You want to actually see how your architecture performs under real-world conditions. So again, I'll skip through the different components there. Now, in terms of how we offer the assessments, it's broken out into 3 sections, if you will. Scalability, basically determine the system's ability to support a specific number of clients while maintaining an acceptable amount of link performance. And then stability, and this is a critical component because it's one thing to get a snapshot in time or a pinpoint glimpse, but what we do is we actually generate this load over time. So you can see peak usage hours, see how things roam during non-peak times, et cetera, in different conference rooms, during meetings. All these elements are taken into account over stability. So we do this by generating actual load over time. And then, of course, we'll go into the coverage as a third aspect. Not only link and RF and roaming and rate versus range type, but also how the link experience is per client device. How is it on this brand of tablet or this smartphone or this laptop? We can get that granular, and this way, that's how we kind of also leverage what we do for the link qualification program for devices. And the steps that the assessment's actually broken out into falls into our discovery phase, where what we do is we come out and actually assess the way the architecture is set up now, make sure there's a clear picture on, so we understand the scope of the way the architecture is set up today. Then based on that, we model traffic off the actual load. Everything is indicative of what you would come across today. We will then model our load generation to mirror that, and we can always tweak and adjust it. From there, we generate the actual traffic via the traffic simulation piece over time. And at the end, we conclude it with a report. And what the report will do is not just simply say, okay, well, at this point in time, here's how things look. It will actually then go into making recommendations on how to optimize for performance, especially for link deployments, what adjustments need to be made so that the link experience is really dialed in. Okay, and that's, again, taking it from the step of just RF coverage into really dialing in the ecosystem. Some examples here you'll see in terms of recommendations, whether the APs cannot support QoS at the targeted scale. Well, here are some things you can do to remedy that. Degraded link experience during busy hour. Again, we'll then offer some advice and basically different adjustments you can make to help optimize that experience. Next steps are also offered in terms of kind of digging a little deeper into what changes can be made in terms of reconfiguring the network, upgrade network capacity, or sometimes it's maybe changing your IT policy for BYOD. Certain clients work better with link experience, especially during roaming. Other clients don't work as good. We can really help dial that in case you do want to go ahead and set forth an IT policy, kind of governing what devices can and can't be used. Now, if not only do we work with the localized IT user, but also with a lot of partners and integrators. So if you're a partner or integrator, this is something that we can easily partner with you to go ahead and offer that as a portfolio addition. And in terms of getting more information or inquiries about the Wi-Fi assessment process, you can feel free to send out an email to us. Again, we work with Microsoft very closely. We've been very fortunate. It's a great partnership, and even aside from the test house qualification programs, but really leveraging that to further the partnership into offering these types of baseline assessments. Okay. With that, again, in recap, the 4 phases of the assessment, and this traverses whether it's WAN or whether it's localized Wi-Fi. It's the same process model, just slightly different version of the tool sets. Discovery, traffic modeling, then the actual traffic simulation, and then a wrap-up report showing all the findings as well as recommendations and adjustments that can be made. Now, in terms of some of the programs that Pascal referred to, for AP qualification and soon to be announced the client device qualification program. If you are curious as to whether the devices in your ecosystem are indeed qualified, you could always go to the Microsoft site and validate that. If they are not, you can feel free to either contact us, or you can go ahead and contact your vendor and have the vendor contact us, and we can then further discuss getting them qualified into the program. We do actually have the Microsoft test plan, so we execute, and as Pascal pointed out, very lengthy, comprehensive test plan, but we'll go through all permutations and ensure that the device is indeed Lync qualified. And with that said, sorry for the speeding through, but I noticed we were out of time, so I don't know if you want to open up for Q&A.
Well, I'm not quite sure we have enough time
maybe
for
not.
Q&A, but we'll be available at a booth around here. Please fill the evals. Let us know how we did, and thank you so much.
Yep, thank you.